There are these creatures that came from off-world. These are untouchables. NASA, renowned for its critical disclosures, has in reality uncovered that this new planet isn't simply hypnotizing considering its size and region, but also because it shows lights that appear to be fake. Are we essentially uncovering insider facts that could change our perception of the universe? Could this exposure mean there is life on other planets? Accompany us as we explore NASA's enchanting discoveries and uncover the truth behind these astonishing lights. In 2007, NASA launched the Dawn shuttle with a mission to investigate the most fascinating objects in our nearby planetary system. Dawn was specially outfitted with 3 ion engines, allowing it to undertake an extraordinary journey. Dawn's mission began with a 14-month examination of Vesta, the second-largest space rock in the belt. During this time, Dawn sent back detailed images and data revealing Vesta's mysterious surface and various geological features. After completing its primary mission at Vesta, Dawn set out on the second and perhaps most captivating part of its journey, a close examination of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and embark on a mission to reach Ceres, an achievement that conventional chemical propulsion would have found challenging. These engines, providing a gentle yet persistent push, enabled Dawn to travel vast distances efficiently and enter a stable orbit around Ceres. First discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For a long time, it was considered the smallest dwarf planet in our solar system until its renaming in 2006. With a diameter of around 950 kilometers, Ceres is the largest and most massive body in the asteroid belt and one of the most interesting due to its unique attributes. As Dawn approached Ceres, scientists eagerly awaited the first detailed images of this enigmatic world. They saw bright spots scattered across its surface, most notably in a large crater, now known as a Cater crater. These bright spots sparked immediate interest and speculation among mainstream scientists. Before Dawn's mission, the best image we had of Ceres was a blurry, low-resolution photograph taken by the Hubble Space Telescope. Experts knew little about this dwarf planet, and the prospect of finally getting a close-up view was thrilling. What secrets would Ceres reveal? What new discoveries awaited? The Dawn mission promised to enhance our understanding of the formation of nearby planetary systems and the role of water in shaping planetary bodies. The bright spots on Ceres were unlike anything seen on other asteroids. They appeared to be made of highly reflective material, possibly salts left behind by sublimated water. This suggested the possibility of cryovolcanism on Ceres, a process where volcanoes erupt with water or briny fluids instead of molten rock. But what exactly are these mysterious lights, and what do they reveal about Ceres? Could they be evidence of ongoing geological activity, or something even more extraordinary? Ceres stands apart from other celestial bodies in the asteroid belt due to its size, mass, unique composition, and potential for water and ice. Unlike most rocky asteroids, Ceres has a structure more akin to a comet, suggesting it holds more secrets about the early solar system than we ever imagined. After 2 years on its journey, the Dawn spacecraft finally began its approach to Ceres in mid-2015. This moment marked a major milestone in the mission, as Dawn was able to deliver humanity's first close-up views of the largest object in the asteroid belt. As Dawn moved closer, the images of Ceres became increasingly detailed, offering glimpses of a world once shrouded in mystery. The first images revealed a surface dotted with craters, typical of a long history of impacts. However, it wasn't just the craters that caught the attention of scientists and space enthusiasts alike. Among these features were unusual bright spots that stood out starkly against the darker, rough terrain. As the images continued to improve in resolution, mainstream scientists buzzed with speculation about the nature of these bright spots. Were they ice patches reflecting sunlight, or could they be something even more remarkable? Speculation ranged from mineral deposits to potential signs of cryovolcanic activity. Remarkably, Closer examination revealed that the brightest spot was not a single substance, but rather a collection of several distinct spots. This discovery only deepened the mystery. The hypothesis that these were deposits of salts left behind by sublimating water gained traction. This would suggest that Ceres had, or still has, some form of geological activity capable of transporting water or briny fluids to the surface, where they quickly evaporate, leaving behind bright reflective deposits. These discoveries challenged existing ideas about Ceres, revealing it to be a more complex and dynamic world than previously thought. The presence of such features raised the possibility of subsurface water or briny pockets, which could have significant implications for our understanding of the potential for life in our solar system. But what makes Ceres noteworthy compared to other planets? Ceres is a fascinating world, often described as a cold planet with a rough yet porous surface. Unlike most asteroids in the belt, which are made primarily of rock and metals, Ceres stands out due to its unique composition. Its surface is a mix of water ice and hydrated minerals, including clays and carbonates, which give it a significantly less dense structure compared to its neighbors. This composition suggests that Ceres contains a large amount of water. The surface layer is rough but porous, with ice and other volatiles trapped inside. This icy characteristic is more reminiscent of a comet than a typical asteroid, suggesting a history that may have involved a mix of rocky and icy materials. Digging deeper beneath its surface, Ceres reveals even more intriguing aspects of its structure. The dwarf planet is believed to have a differentiated interior consisting of a slushy mantle and a core. The mantle is thought to be rich in water ice, making up about half of Ceres' total volume. This mantle, possibly a mixture of rock and salty water, surrounds a core that may be composed of denser material, possibly silicates. The presence of such a large amount of water ice suggests that Ceres may have once held liquid water, particularly if its core was heated by radioactive decay early in its history. This internal structure sets Ceres apart from its asteroid neighbors and also raises fascinating questions about its potential for geological activity and the role of water in its evolution. However, that's not all. The discovery of ammonia clays on Ceres suggests that the dwarf planet may have formed in a colder part of the solar system before migrating inward. The presence of ammonia lowers the freezing point of water, supporting the idea of subsurface brines. These insights into Ceres' structure and history not only enhance our understanding of this intriguing dwarf planet, but also offer important clues about the processes that govern the formation and evolution of icy bodies throughout the solar system.